Hello everyone. So today we are going to solve this question, game 2048. Okay, it was in ICPC prelims. It was a D question, and that prelims got rescheduled because of some technical issues. So in this problem, what we have given that you have 10 raised to 1000 tiles. What does it mean? That it's like we have unlimited supply of tiles. Okay, and initially each tile have number 2 on it, okay, written on them, and we can perform following operations as many as time we want. Okay, so what's operation here? We can take two existing tiles, okay, with same value x, okay, and we will combine to form a single tile, okay, and the new value will be 2x. Okay, so if I'll combine two tiles of x value, the new tile will be of value 2x. Okay, it's like the game we play, where we combine 2 and 2, then it becomes 4, then another 4 and 4 becomes 8. It's like it's the same replica of that game. Okay, now here they gave us an example. If we have two tiles of 4096 value, after combining it, it will be the score which will add into our total score. It will be 8192. Okay, like consider that we have some already Y score. Okay, and we currently have two tiles of 4096 value, and after combining them, the score will increase by 8192. So it means that the new score will be y plus 8192. Now we have given some integer y. Okay, now we have to count the number of distinct final configuration of tiles possible such that our score will be exactly y. Okay, and now what they have given, like two configuration are considered distinct if for some integer x the number of tiles with x written on them is different between both configurations. Okay, like we actually what we want, a different type of combinations. Okay, where uh, if in first set I have two tiles of 4, okay, and in another I have only one tile of 8 value. This they give us same score, but what we'll do, we'll consider two different configurations. Now we have to answer modulo this value 998244353. Okay, now given inputs, we have some test cases 10 till 10 raised to 6 and y value 4 into 10 raised to 6. So first what we'll do, we will first see why we are getting this output. Like uh, first, whenever you look at this question, you'll get confused, like why 4 has 1, then 8 has only one value. Like it's possible that we can have two tiles of 4 and one tile of 8, or four tiles of 2. So for 8 it should be 3, but what you are forgetting, that we want score. Okay, these are the score, we want this score, and for this score how many different configuration of tiles. So see what we have: 2, 4, 8 and 32. See, okay, 32. Okay, now see, um, we already have all tiles with number 2. Okay, and if I'll take any two tiles and combine them, already our currently score is 0. Okay, the new score will be 4, and s will directly it will directly go to the 4. So we can't achieve score 2 in any means. Okay, because we already have tiles of 2, and even we add any one pair, it will give us the score of 4 because the new tile will be 4. So there are 0 ways to do this. Now to reach 4 score, we can only have 2 tiles of 2. This is the only configuration. So 1. Now for 8, okay, for 8 only configuration is 2 tiles of 4. Why? Because from, like, why we can't have like this 4 and then 2 and 2? Because these tiles will not give us any score. For tile with value 2, the S is 0. Okay, this is the problem with this. For 2, we are not going to get any score because initially all are 2. So for it, only possible configuration is 4 and 4. A tile of 4 will give us score of 4. A tile of another 4 will give us score of 4. But if we combine them, okay, like another case was like, why can't we have only one tile of 8? Why? Why we can't have? Because if I have configuration like this 8, okay, I have tile 8. So for when I'll create a tile of 8, how many score I'll have? Okay, so for uh, where is undo? So when I created one tile of 4, I got score of 4. For another tile of 4, I got score of 4. And when I combined them, I got score of 8. So when I'll have a tile of 8, okay, I will not have score of 8. I will have score of 16. So this is the thing where so many people got confused, that here these are the scores and we have to tell configuration in term of tiles. Okay, so for 32, now see for 32, when you'll see the cases for 32, all three cases, you'll realize that how you have to do it. For 32, okay, before that what we'll do, we'll map everything. Okay, see, we'll what first what we'll have, a tile. Okay, here I have a tile, and if I'll have a single tile of that value, how much score it added, okay, to my cumulative score, okay, total score. So when I had a tile of 2, I had a 0 score because initially every tile had number of 2, okay, the value was 2. So having a tile of 2 will add 0 to the score, nothing. A tile of 4, it will add score of 4 because I added 2 plus 2. Okay, after adding 2 tiles of 2, I got score of 4, which got added in this score, and it gave me score of 4. So total in the total score of value of 4 got added because of creation of one tile of value 4. Next one is 8. Okay, you can see whatever tiles are possible are always power of 2. Okay, when I created one tile of 8, how much score got added? Okay, so how I got 8? Okay, like how I got that tile of 8, when I added tile of 4 plus tile of 4. Okay, but tile of 4, when when we had tile of 4, okay, that tile already added some score in the game. Okay, so it was 4 plus 4. Okay, and when I created a new tile of 8 using these two tiles, the score got added was 8. So 8 give us score of 16. Now for 16, it will be the score. we got by two tiles of 8 and 16 itself, because we created a new tile of 16, so we got a new score of 16 added into our total score. So what it will be? It will be 2 into 16 plus 16, which will be 48. So if you look at this procedure, what's happening? If I'll say I have val power of 2 comma I, because all are the we know that all tiles are power of 2. So what it is? It is 2 into val of power of 2 comma I minus 1, okay, and plus uh, power of 2 comma I, because we are getting power of 2 comma I as a new tile, so this will score will get added. Okay, this is the score we got into our total score at that time, and this was the score we already had. Okay, okay, this score was already there before the creation of that tile. So now look at the condition, like look at the possibilities for 32. So for 32, now what I know these things. Create having a single tile of 2 give me score 0, having a single tile of 4 give me score 4, having a single tile of 8 give me score 16, having a single tile of 16 give me score of 48. So now to create 32, okay, I have to see combinations I can create from this score. Okay, to have a 32 score, I can have 16 plus 16 score. Okay, 16 plus 16 score, and 16 plus 16 score, what does it mean? It means that I have two tiles of 8. So I have two tiles of 8. Okay, I'll denote like this, T8 and T8. So you will not get confused in the where is the score and where is the tiles values. Okay, so these are the tiles. Okay, we have a two tiles with value 8. Another possible configuration for creating 32 is like having 116 and 4 fours. Okay, 16 plus 4 plus 4 plus 4 and plus 4. Okay, so it's T8. Okay, T8 plus 4 into T of 4. Okay, 4 tiles of T4, and even we split that 16 into 4 tiles of 4. What will be the new configuration? It will be T of 4. How many tiles of value 4? 8. These are the three possible configurations. If you look test cases, we have answer 3 for 32. So now let's see, this is the editorial. Now what was the hint one? It was how much score will you get when you make a tile of value x. Okay, and the note was x will always be power of 2. We already discussed that whichever tile will have, it will be power of 2. So what was the first hint? How much score will you get when you make a tile of value x? We already we already find it out. So for tile 2, score 0. For 4, it's 4. For 8, it's 16. For 16, it's 48. And for 32, I think it's 128. Okay, so we'll have this kind of array. Okay, now another second hint is to reach score of s. Can I use some tiles multiple times? Yes. In this configuration, we use 4 tiles multiple times, even tile 8 multiple times. Hint 3. Think of DP, especially the standard coin change problem where we have to calculate ways to get the amount X using a given array of coins where we can use a coin multiple times. So if you can see here, when we were trying to see what are the three possible ways for 32, what we did, we chose some values from this. Okay, sometime for a case we took 4 8 times. In a case we took it for 4 times. In the first case we took 16 2 times. So we can take these values multiple times. So we turned this problem into a coin change problem. Okay, a standard coin change problem in which we have to get an X value where we are going to add some A1, A2, A2, A3 multiple times. Okay, we can take any value multiple times and we are going to get this sum X, and we have to say we have to just say how many ways are there. So now what's the solution? See, so let's first see how much score I will have when I'll create a tile of some value. Okay, we already saw that uh, when we'll create a tile X by adding two y tiles, my score will be what it will be, the score of y into 2 plus x. It is same as value of power of 2 comma I, where 2 comma I is our x tile and power of 2 uh, 2 to the power I minus 1 is our y tile. Okay, so it is 2 into score of y plus x, which is score of x. Okay, now score of y is score I got by creating tile y by some previous operations. Okay, for 2 it's 0. Okay, because initially all tiles with value 2. After 4 have value 4. When we'll create a tile of it, the score will be the 16. For 16 it's 48. Okay, now the question remains that how much such numbers we will need. Okay, so what uh, what is given in our constraints, that the value of y is less than equal to 46. Okay, so we have to go till that I, such that 2 raised to I plus 1 will have score which will be greater than this number. Okay, just we have to go till the lower bound of this 46. So you can see that array of size 23 will be enough, like 2 raised to 22. Okay, the tile with value 2 raised to 22 will have score which is very near to the 46 value, and for 2 raised to the tile with value 2 raised to 23, it will exceed value 46. So we really don't need that. So our array will look like this: 0 0 4 16 48 128. It's the same as this. Okay, 0 a 0, then 0 4 16 48. Okay, so what does it say? That 4 says that this is the score I'll get when I'll create a tile of 2 raised to I. Okay, I just converted that instead of like, also we can do this like this, we'll map values, like map of 2 equal to 0, map of 4 equal to 4. Okay, we'll create map of int comma int. But instead of that, what we did, we just created an array where um, value will be at the ith index. It will be the value for the tile 2 raised to I. Like, we just compressed our values, so it will fit uh, in an array. Okay, now to make score of s, you can simply do a variation of coin change problem. Okay, See, this is problem. Mm, this is the same problem, okay, where we have to say number of ways. Just modulo value is different, and we have given n integers and x value. Here same. We have these n values and some x value. Okay, this s is same as whatever x is here. So we just have to put the template from this problem into this problem. Now, what I did, I coded a recursion code. So maybe you could understand from it that how the transitions are going in DP, but it will give us TLE. Okay, like when in in the second practice contest, which was after this contest got rescheduled, on CodeShip I submitted this solution and it gave TLE. Okay, and when I run it locally, it will probably be give us MLE, because this is 2D DP, which is literally going to make a vector of size 1e8, okay, which is not possible. So we'll see both solutions. Okay, so see, first thing is we have to create that array. Okay, array with scores. Okay, we have this prefix array, and pref of I is how much score I'll have with a single tile of 2 raised to I. So it will be the same, the score will be 2 into previous two tiles, sorry, previous tiles, score by previous tile into 2 plus that new tile, okay, which is 2 raised to I. Okay, I use bit manipulation here to get 2's power. Now, in recursion, what we really need, we can start from index 2, because for index 0 and 1, what is for index 0 is 2 raised to 0, which is value 1, and 2 raised to 1, which is 2. For both of them, the score is 0. So even we take those tiles or not, it's not going to add any score. Okay, so what we are doing, uh, we have 2D DP where DP of ij is, if I'm just doing pick or not pick DP. Okay, if my index is 23, like I reach the end of the array, and if my require sum is 0, then this configuration is possible. Else this configuration is not possible. Okay, I'm returning it. If I'm already calculate that DP state, I'm returning it. Okay, if I'll not consider that tile, okay, the tile at index idx. Okay, so I'll increase the index, and the require sum will remain same. If I have to take, okay, but if I have to take my require sum minus whatever score that tile is giving, okay, their difference should be greater than or equal to 0. Then only I'll take, and if I'll take, I really don't need to increment my index, because I can take it multiple times. So my index will remain same. My require sum will get decreased by the score by that tile, and after that I'm just returning summation of this. Okay, what I really need to edit is just need to return mod. So this is the recursion code, but it will give me error, TLE error. So what we need to do, we need to convert this into an iterative code where our it's okay to time limit with 1e8 operations, but memory should be of 4e6. Okay, so this is code by my teammate. Okay, he used iterative DP. So this process is same. Okay, first we created that array with scores, where pref I will be score of uh, score of whatever score we are getting by creating one tile of 2 raised to I. Okay, now I have dp of what we did, we first calculated for all values. Okay, and after that for every query we can now answer in just O of 1. Okay, so dp of 0 1, it's same as in this code. When our required sum is 0, we considering that we have a possible configuration. So dp of 0 says for 0 we have one configuration. Now we iterated over uh, the array of score, and then iterated over the scores, all possible scores we have. And if score, okay, the required score minus score from the given array is less than 0, then we are continuing. Okay, uh, we can't add a tile in it. Okay, and in another condition we are adding just the possible ways to uh, okay, give me a minute. So here what we are adding, whatever the possible ways we already had with the making a score of j minus prefix of I. Okay, and we are taking the mod. So this is the this is the same solution as the intended solution in CACS coin change problem. I'll show you. We will see this solution. You can see this solution is same. First I'm iterating over the given array, then all possible sum, then if sum minus value from array is greater than equal to 0, then I am only doing adding the last possible, like for dp of j. Okay, for creating like the ways for dp of okay, if how much way I can have for some value x. Okay, so it is whatever values I can have at x minus some values from arrays. Okay, if that's possible. Okay, we are first checking here, is it possible that whatever sum I need, okay, minus a value from array. Okay, because I have to pick from that array only. If this is greater than equal to 0, okay, so I can take that value, I can take this value, but taking that value, how much configuration will that add? It will add whatever configuration I had when I had a score which was less than by this value. Okay, how it is. Okay, I want to see how much dp of x is. Okay, I want to see how much dp of x is, and I'm saying that as is possible. Okay, as is possible, I can take s value because x minus s is greater than equal to 0. I can take a score of s to create a total score of x. Okay, now how much of configuration will get added into x? So it will be like dp of x minus s will get added. Why? Because it says that I want this much of value. Okay, this is x and this is value s. Okay, so the only possible is whenever I'll have x minus s sum. Okay, I already have x minus sum, then only I can add s into it to get x value. So this value we need to add to get our dp value for x. So we are doing iteratively for all possible values of sum, and at last when we got all dp states for every value, what we did, we just took input for x and printed dp of x. So this was the solution, and it was really easy. If you got an idea about how to just create this thing. Okay, if you come up with this thing, you have to just use a standard technique of coin change problem. So this was the question. Thank you.